subject irrigation engineering, chapter soil water constants, topic saturation capacity, field capacity and permanent wilting point. Now students, we have started a new chapter which is the soil water constants, right? So in soil water constant, this chapter is very important because I have seen in past 3, 4, 5 years in GATE examinations, questions are very frequent from this topic, that is the saturation capacity, field capacity and permanent wilting point, right? So now before understanding these three terms, I would like to know from you that if there is a, let's say suppose we have some soil, right? We have some soil. Let us say that I am taking a soil. Let us say this is a soil, right? I am taking this soil. Okay. The depth of this soil, let us say it is D, right? And the surface area is 1 meter square. This is 1 meter and this is 1 meter. So I have taken a particular cube sample of the depth D and length is 1 meter and the width is also 1 meter. For example, okay. Now this is soil, okay, this is soil. Now let me use another marker. Let us say this is soil. Soil particles are there, right? Soil particles are there. Some voids will also be there, right? Some voids will also be there. Some voids with air molecules will also be there. Now if I put some water, let us say this is incoming water stream. This is incoming water stream. Now if I put some water on this soil sample, where will this water go? Where will this water go? So this is my common sense. Even in my when I was a kid, I used to play with soil. I used to make some toys with soil, right? What I notice is that if I pour some water on a particular soil sample, some water will be retained. Where will it be retained? It will be retained inside the pores, or can say inside the voids, right? So it will be retained inside the voids, and some water will come down. So this is my common sense. This is my common observation, which I even observed when I was a kid. You must have observed this thing also, right? So some water will come down, some water will be trapped inside the pores. That is known as the water holding capacity. I'll be coming to that topic also, water holding capacity of soil. Some water will be coming down. Okay? So this is everybody knows that the water which will be held by this soil sample, it will be inside the pores or inside the voids. Clear? Simple. Now let us define two terms which you have already discussed in your geotechnical engineering portion. So the first point is known as the porosity. Porosity, which is denoted by N. So what is porosity? It is volume of voids divided by total volume. Now can I also write this sample as like this, the three-phase system, which you have already done in your geotechnical engineering portion also. So this is your air, this is your water, right? And this is your solid, volume of solid, right? This is volume of solid, volume of water and volume of air, and volume of air plus volume of water is known as volume of voids, and this is volume of solids, if you remember. Clear? Now this is porosity. We have another term that is known as the void ratio. Void ratio, that is denoted by E. E is equals to volume of voids upon volume of solids. And you must be knowing, even in your geotechnical engineering portion, you must have seen that we prefer using void ratio over porosity. What is the reason? The reason is that in porosity we have the total volume. So this total volume can change, because this total volume is actually equal to volume of solids plus volume of voids. Volume of solids will be constant. Whether you compress soil, whether you do anything with soil, the volume of solids will be constant, but the volume of voids can change. That is why it is a very changing parameter. As far as void ratio is concerned, volume of solids is constant. So that is why we prefer void ratio over porosity. This thing you must have studied in geotechnical engineering portion, right? Okay. Now coming to the next part, the pores. The pores inside this soil sample, these pores are known as, actually divided into two parts, right? So I can say that the water hold by soil sample, water hold by soil sample inside pores. And these pores are of two types. So first one is the capillary pores. Capillary pores. Another one is the non-capillary pores. Non-capillary pores. Now, what are capillary pores? You must have studied in your fluid mechanics, because I am relating on topics, because in civil engineering every topic is related to one another, right? So in your fluid mechanics, you must have heard, even in the soil mechanics also, you must have heard about the capillary action. So what is capillary action? Let me again remind you that suppose that you have two soil particles. These are the two soil particles. So if you have, you can say, water between these two soil particles, right? So if you have water between these two soil particles, now due to the force of adhesion, now what is adhesion? The force of attraction between two different molecules. So between force of adhesion between water and the soil particle, this water particles, they will rise up due to the surface tension also, right? Okay, and this is known as the capillary action. If you remember, this is known as the capillary action, right? So we have capillary pores, right? So capillary pores, it has been found that they are small in size. Clear? Another thing which has been found about the capillary pores is that they can hold much amount of water against the action of gravity, because gravity is acting in this direction, upward to downwards, and this water is going from downwards to upwards, right? Okay, and if you remember in fluid mechanics, you must have studied that the height of capillary rise, it actually equal to 4 sigma cos theta upon rho into G into D, if you remember. Now what is sigma? Sigma is the surface tension. Clear? So the capillary pores, they are small in size. Clear? And they can hold much water. They can hold much water against force of gravity. Clear? Example are clays. Right? So these are known as the capillary pores. Now coming to the next type of pores, known as the non-capillary pores. Clear? Now non-capillary pores, they are opposite. So you can say that they are large in size. The second thing about the non-capillary pores is that they can hold less amount of water as compared to the capillary pores. So they can hold less water, and the example are sands. So these types of pores are there, right? So water will be inside pores. It can either be inside the capillary pores if it is clay, or it can either be inside of non-capillary pores if it is sand. Simple. Clear? Okay. Now let me go to the next topic, next part. In this, you can say, in this topic about, we have understood about the capillary pores and non-capillary pores. Now let me teach you what are different types of water. Now you must be asking, sir, we have only one type of water, that is H2, right? Well, yes, we know that is it. You can say state of water is liquid, that is H2O. But again, if we are talking about the irrigation engineering or fluid mechanics, or even in your geotechnical engineering part, we actually have 4 types of water. Now let me tell you what type of waters are there, right? So let me rub this. I hope you are getting this, right? Because questions are asked, theoretical questions are asked from this topic: the capillary pores, non-capillary pores, which one is smaller, which one is higher, how much you can say capillary rise is there in soil, which you must have studied in your geotechnical engineering portion. You must learn the values, right? That how much capillary rise is there in soils. Okay. So now let us discuss about the types of water. Types of water, and I will make you understand the types of water with this same. Let us say that this is the cross section area of a soil sample. This is 1 unit. This is also 1 unit. The width is also 1 unit, and the depth is D. D unit, like this. We have a particular soil sample, right? We have soil particles. We also have voids and something, right? 3-phase system. It is there, right? So we have 4 types of water. The first type of water is known as the gravity water. Now what is gravity water? Now you must have seen that I told you that this is a particular soil sample, right? Okay. If I pour some water on it, it can be 1 meter cube of water, 2 meter, whatever water I am pouring in this soil sample. Some water will be held by this soil sample and some water will go downwards, it will come out. This water which comes out due to the action of gravity, simple, right? Because it is coming down due to the action of gravity, because gravity is acting upward to downwards, right? And this water which comes out due to the action of gravity is known as the gravity water, right? So I can write it like this. Do I need to write it? I hope that you have understood, but still I am writing it, right? Okay. The water which comes out, right? Or which you can say, which travels, you can say, right? Which travels, that would be more appropriate. Which travels due to the action of gravity. The action of gravity is known as the gravity water. Simple. Now, second type of water is known as the capillary water, right? Second type of water is known as the capillary water. Right? Now, what is capillary water? Again, I have made you understand that what is capillary water. Some water will be retained by this soil sample. Sorry. Some water will be retained by this soil sample. Let us say that this is the soil molecule, soil particle. This is a soil particle, soil particle, soil particle. So some water will be retained in between the pores, right? So in between the pores, some water will be retained in between the pores. And due to the forces of adhesion and surface tension, is very important that capillary water is due to surface tension, right? Is due to surface tension and adhesion, right? These two forces are acting, right? So it will rise to some amount, right? Or you can say it will be held by the soil molecule or soil particles, and this water is known as the capillary water. Clear? And this action is known as the capillary action. The third type of water is known as the hygroscopic water. Let me use another marker. So third type of water is known as hygroscopic water. Hygroscopic water. I told you that civil engineers play with words, right? Even if you don't know, even in interviews or even in examination, if some theoretical question comes and you don't know what is the answer of this question, just go to the word hygroscopic. This word you must have heard in your class 12th also, right? So